Determine equation of the graph. So here we have a sinusoidal function and we need to write the equation for this graph. In general, we can write the formula for a sinusoidal function as f of x is equal to a times function, which could be sine or cosine, k x minus p plus q. Right? Where a is the amplitude, k is number of waves in 2 pi period, p is the phase shift, the initial point, how much it has shifted left or right, and this is the vertical shift of the axis, up or down. Correct? Now, how do we really find all these values? Well, a, we can find amplitude as from maximum and minimum value. Amplitude a for a function is equal to maximum minus minimum divided by 2. Q, the axis of symmetry, can be calculated by as an average of maximum minimum. So it is maximum plus minimum divided by 2. And k, you can count literally how many waves are there within 0 to 2 pi and fill it up, right? So from here, like 1 and then 2. So we are expecting a value kind, so it's from here 1 and then 2. Okay. Anyway, the other method is for k as 2 pi divided by time period, number of waves in 2 pi. Or if you're doing it in degrees, then it is 360 degrees divided by time period, correct? So either way. Now since this graph is from minus 2 pi to plus 2 pi, we will be writing the equation in 2 pi radians, correct? So that is what it is. Once you get a graph, it is a good point to check your scale also. So the scale here is, let's see how many divisions are there which are dividing 2 pi. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 divisions which divide 2 pi. So each division is 2 pi divided by 12. Okay. So we'll write this as each division here as 2 pi. Let me write here 2 pi divided by 12, which is pi by 6 for us. So each division here is pi by 6. Right? Counting divisions, we can find the time period. Right? So now let's figure out the real values of a, q, and k. Now to find a, as I was saying, you need to figure out what is maximum and then what is minimum. So maximum value is 1 for us. We say, well, maximum is equal to 1, minimum is equal to minus 1. Right, and therefore a should be maximum minus minimum divided by 2. That means 1 minus minus 1 divided by 2. That gives us 2 divided by 2 as 1. Similarly, q we can find, q is average, add them, divide by 2. So 1 plus minus 1 divided by 2, which gives us 0. So q is 0 for us. As soon as you get the value of q, you draw your axis of symmetry. In this case, that is the x-axis. That is my axis of symmetry. Okay, now we've got axis of symmetry. Now let's figure out what is the time period. To find the time period, we need to find good points from where we can count as starting and ending of a wave. Now here, this could be a good point, right? So we can say, well, from here, let's count. From here, 1, 2, 3, 4, 5, 6. So it starts 6 divisions, right? So 6 divisions means each division is pi by 6. So it is 6 times pi by 6. Or you can say like this, each division is pi by 6. So 1 pi by 6, 2 pi by 6, 3 pi by 6, 4 pi by 6, 5 pi by 6 and 6 pi by 6. So the time period t is 6 pi by 6, which is pi. Do you get it? So our time period is pi, and therefore k will be equals to 2 pi by t. T is pi for us, and so we get k as 2. As I was saying, k is another way we can evaluate k just from the graph. In 2 pi, how many waves do we have? So we have one wave and two waves. So that is the value of k, so we get 2. Now the critical point for us is to find the phase shift, which is the value of p. In this particular graph, we notice that the maximum and minimum values are not at a good point for us. They are like mid of the value. But starting point of a wave is well defined. So sine wave is a much better option to go for in this, if not specified, right? If you have a choice, sine wave is a good choice. So we can say, well, this is a good starting point for a sine wave, correct? So it starts when? It starts early on, right? So that is my y-axis and starts 2 units before. That means 1 pi by 6, 2 pi by 6. So p here is minus, because going there. So p is, for a sine wave, minus 2 pi by 6, which is same as minus pi by 3. So that is the p value. There is a phase shift towards the left by pi by 3. This is for sine wave, right? So that is for our sine function, correct? So we got all the values here. So we can always write down our function now. And therefore, our function can be, so let's revise and put each value clearly here. So what do we get? So here we have a as 1. So you get a as 1, q as 0, k as 2, and p as minus pi by 3. So we'll plug these values here and write down our function. So our function f of x can be written as a times, and the function we selected is sine. So we use sine, k is 2, x minus of minus pi by 3, that means plus pi by 3, plus 0. Do you see that? So that is how we get our function. Okay? So that is the way to write equation of a sinusoidal function. I hope by now you got enough practice, and there are few more to come. And I'd like you to write the equation, stop the video, write the equation first, and then check the answer. Thank you.